This next clip has for a subject titration. There are two main types of titration: acid-base, and a second type called redox. Redox stands for reduction and oxidation, and we'll talk about redox at the end of this course. And today we'll be talking about acid-base titration. And titration is very much a topic which is explored in Chem 2070 labs. Titration can be thought of as a converse to limiting reactants. In limiting reactants, you start off with two chemicals, the reactants A and B, going to, let's say, two products, C and D. And in limiting reactants, there's either too much A or too much B, and either all the B gets used up first or all the A gets used up first, leaving excess behind. In titration, and we're going to look now at acid-base titration, the converse happens. We're going to react an acid, HA, plus a base, B, to make the conjugate base A minus and the conjugate acid HB plus. And we start off with an initial number of moles of HA and an initial number of moles of B. And titration really is about the case when the number of moles of HA exactly equals the number of moles of B. When the number of moles of acid and the number of moles of base are equal, this is called the equivalence point in a titration. And when we say we titrate something, it's shorthand for at reaching the exact equivalence point in titration. And so let's look at a problem. The problem we'll look at is how many milliliters of 1.24 pH HCl solution are required to titrate 21.4 mils of 0.16 molar NaOH solution. And as in all 2070 questions on acids and bases, we'll be dealing with strong acids and strong bases. HCl is a strong acid, and NaOH is a strong base. And all strong acids end up producing H plus. In water, the acid becomes H plus, and the base becomes OH minus. And so the kind of reaction we're going to do is always the same here in acid-base in 2070. It's the reaction of H plus OH minus to H2O. And we now want to enter, we're going to do a very simple diagram. We want to enter underneath it the number of moles of each. So let's first deal with the base. We have 0.16 molar NaOH. NaOH is a solid, and it dissolves to Na plus aqueous plus OH minus aqueous. So I have 0.16 molar if the NaOH concentration is 0.16 molar. That means that the OH minus concentration is also 0.16 molar, which is 0.16 moles per liter. And how much NaOH do we have? It's 21.4 mils. Well, the former thing was in liters, so we need to convert. 1,000 milliliters is 1 liter. And so when you do the math, you get 0.0214 liters. And now we can figure out the number of moles. 0.16 moles per liter times 0.0214 liters. The liters cancels, and we get 0.0342 moles of OH minus. And we enter that right here. Now, put into chat, this is the titration, put into chat the number of moles of H+. Remember, by titration we mean at the equivalence point. Put it in chat, how many moles of H+. Correct. We have 0.0342 moles at the titration point of H+, because they are in a 1-to-1 ratio at the equivalence point. Okay, so now what are we going to do? We will look at, we want to figure out the volume of the HCl solution, and what we have is that it is 1.24 pH solution. That means that the H+ concentration is 10 to the minus 1.24, and if you plug that into the calculator, you'll get it's 0.0575 molar, which is equal to 0.0575 moles per liter. And what we want to know is the volume of the HCl solution, which will be in liters. So, how do we do that? Well, the 0.0575 moles per liter times the unknown volume of the HCl solution. The volume of HCl is in liters. The multiplication of these two is moles. How many number of moles are they equal to that? Put it in chat. What am I supposed to write right here? The number of moles right here. Put that into chat. Yes, by the titration, because we're actually talking about the equivalence point, it has to equal 0.0342 moles. And that means that the volume of HCl is equal to 0.0342 moles. Divided by 0.0575 moles per liter. The moles cancels. This will be in liters, and we get the final answer of 0.0595 liters, which is, if we multiply by 1,000 milliliters, is the same as 1 liter, equals 59.5 milliliters.